Okay, today we're going to cover how we can solve systems of linear inequalities. This is going to play on the things that we learned yesterday about linear inequalities. And this covers three standards. Solve a system of linear inequalities in two variables algebraically. Determine whether a given point in a solution set of a system of linear, determine whether a given point is in the solution set. And graph and solve systems of linear inequalities and equations with rational coefficients in two variables. These are all integrated algebra standards. Now the first one we are going to do, so systems of linear inequalities are a lot like systems of equations in that we have to graph, this is the system. Okay, we have to graph them at the same time, and we have to see things that meet the inequalities simultaneously. So we're looking for all points that meet the inequalities simultaneously. Okay, so let's see. X is greater than 2, so that's going to be a vertical line, or this is going to be a horizontal line. The boundary for this is x is equal to 2, and remember it's a dashed line. So here we have here, and greater than 2 means it's shaded on this side. Okay, y is less than or equal to 2, so that's going to be, again, a dashed line here. We're going to shade right here. Okay, so our solution to our system is anything that's in both of them. So S is the solution to the system. Okay, so we are looking for the points where both areas are shaded. Okay, so let's look at some of the points in here. All right, if I picked a point right here, this would be the point, okay, this would be the point 8, negative 3. So I'm going to put this in for x and see if it satisfies it. So 8 is greater than 2, so that's okay. And y is less than negative 2. So see, 2 is less than negative 2. Oh, sorry, that should be 3. Okay, this should be, so negative 3 is less than negative 2, so that is correct. Okay, so this point is a part of the solution set, which is labeled with this capital S right here. Now, a good question is whether or not the point that's on the intersection of the two dashed lines right here, is that point, the question is that point a solution? So let's just check it out. That would be 2, negative 2. So is it true that 2 is greater than 2? So that's not true. And it's not true that negative 2 is less than negative 2. So this point right here is not a solution. Okay, and we are going to find this. If it's the boundary of two dashed lines, if it's the intersection of two dashed lines, that means it's not a solution. Okay, because all the points on the dashed line are not solutions to their individual inequalities, so the intersection of that point is also not a solution. Okay, question number 2, find the solution for the system of inequalities. So this is called a compound. These are called compound inequalities because they're bounded on both sides. So they're bounded above and below. Okay, the way that we graph this is we want all the x values between that have all of the coordinate pairs on this two-dimensional system that have an x value between 3 and 5. So I'm going to go, okay, and then I'm going to put a dash line at 5, and I'm going to shade in between here. And likewise, these are all the y values that are greater than 2 and less than 4. So I'm going to shade in between. Okay, so this little tiny place right here, this is your solution. Okay, and none of the intersection points are a solution because all of them are intersections of two dashed lines. So these points right here are not solutions. Okay, so if we checked one of our values here, let's just check one of these. Let's check this one right here. This is the point 1, 2, 3, 4, 1, 2, 3. This is the point 4, 3. Okay, is it true that that is true? So 3 is less than 4 and that's less than 5, so that's true. Is it true that 3 is in there? Yes, that's true. So this right here is our solution set. We always label it with an S. Okay? All right, finally, let's find a solution to these two things. So these right here are going to be diagonal lines, not just vertical or horizontal. So here we have something written in standard form. So the first thing that you want to do, you can either create a table or you can, so if I made a table right here, X and Y, so 1 and 3 and 3 and 1, 0 and 4 and 4 and 0 are good. So 1 and 3 and, oops. Okay, and it's a solid line because it's less than or equal to. Now you come to the question, which side should we shade? So let's do a test case. Is it true that 0 plus 0 is less than or equal to 4? So this is not true, so I shade the upper part of this. Okay, now let's graph the second one. Okay, the second one is right here. So this is the y. So the boundary is dashed, and it's the line y is equal to 2x minus 3. So I go down to negative 3, and I go up 2 and over 1. Okay, and this right here, let's see, is a dashed line. And again, I'm going to test 0, 0. Okay, is 0 less than 2 times 0 minus 3? Is 0 less than 0 minus 3? Is 0 less than negative 3? And the answer is no. So I am shading on the side that doesn't include that. Okay. All right, so my solution set is anywhere that's been shaded twice. All right, so my solution set is right here. All right, so here is my solution right here. Okay, and it's bounded by this dashed line and this solid line right here. Now always label your solution with an S. That's something that you need to do for the regions. My question is that a solution? So that point is 2, 2. So let's check it out here. So can I put it in the first one? 2 plus 2 is greater than or equal to 4. That's true. So let's put it in the second one. Is it true that 2 is less than 2 times 2 minus 3? So it's not true that 2 is less than 1. So it doesn't work here, so that point is not a solution to system. Okay. Now, so the conclusion here is that the intersection of a dashed line and a solid line is not a solution. To the system of inequalities. Okay, no, it's not a solution. Now another question is something outside a solution? So is that a solution to the system? Okay, and the answer is no. It's not part of the shaded region. Okay. All right, and that's the last example I have for solving systems of linear inequalities. Remember that to always label your inequalities with an S.